I am ENITHA from Artificial Intelligence and Data Science Department in PSN College of Engineering and Technology. Today we have to study about the various types of the data structures. Normally, what is data structures? The data structure is a way of organizing data, not only the items stored but also their relationship to each other, because the various data structures can be available in our real world. Okay, normally the data structures can be organized and process and retrieve and store the data, because the various forms of the data can be available on nowadays. Okay, data can be available in online form, otherwise in offline form. There is streaming data, the medias can be available for retrieving the data, because nowadays the data is the vast amount of the data can be getting is a structured data, otherwise unstructured data, otherwise the semi-structured data. This way the various forms of the data can be available. So now we have to find out the data structure means what? We have to use the data and how to organize the data. Okay, also we have to find out what is the relationship among the data. Here, what are the different classification of the data structures can be shown on the figure. Just you got to see about it. The data structures can be classified into the two types. One is the linear data structure, another is the non-linear data structure. The linear, again we have to classify either the static or the dynamic. The static means array and the dynamic means the queue, stack, linked list, and etc. Also in non-linear data structures can be further classified into tree data structures and then graph data structures. Because the linear data structure means what? The data can be arranging in a sequential manner. But the non-linear, there is a random access, okay, no sequential order. Okay, listen. There is a linear data structure. The data elements are arranging in sequentially. Okay, each elements can be accessed by either its previous or the next adjacent elements. Okay, example is what is a stack, array, queue, okay, etc. So we got to refer as the linear. And then linear can be further classified into the two types. One is the static and then is the dynamic. Static means what? The fixed memory size can be swallowed. Okay, we have to easy to access the elements because all are arranging in a particular location. Because the A of 0, first element can be stored. Then A of 1, the second element can be stored. Is it? Orderly the data can be stored in an array data structures. With the dynamic array structure, stack and queue data structures can be available. You know that. Okay, how to the randomly updating during our runtime. So also what is the advantages for this? That is the efficiently using of our memory space. That is the advantages over the static data structures. So now we got to go for the non-linear data structures. This is various types. The data can be not as placed as a sequentially, because one data can be placed in one location, another data can be placed in the last location or the middle location, or some of the locations the data can be stored. So in that case we got to refer this as non-linear data structures. Tree and graph is the example for this. And first we detailedly studied about what's the array data structures. Now the array means what? The group of related data items that shared by a common name. That is called as the array. Okay, for how to say is the another way is a collection of the elements of the same data type stored in the contiguous memory locations. Because now we got to see the figure. This varies totally. The size of the array is what? Is a 8. It's the length of the array. Okay, here the array index can be varies from 0 to 7. Because the n number of elements can be available in an array, we have to refer as the 0 to n minus 1 elements can be available. The first we got to storing the values is 49, next 46, 47, also so on. Okay, so now we got to accessing the elements means what? We got to referring A of 1 means what? So that time we got to referring one for loop. Okay, the I is varies from 0 to 7. You got to reading the value or writing the value depends upon our languages can be used means what. For example, in our C++ language means what? You got to reading the value, you have to using cin and then extraction operators can be used for accessing the elements. Okay. you got to read the value from the keyboard. We got to using C in next action operator. We got to write as A of I. So that time the I can be varies from 0 to 7. Totally, first the A of 0, what's value? A of 1, next value. Then A of 2 is the another next value. This way you got to read up to A of 7. Totally, the 8 elements can be read from the keyboard. Here, wherever you got to, so various types of the arrays can be available. Okay, it is another way. It's a one-dimensional array, two-dimensional array, and then multi-dimensional arrays can be available. One-dimensional array means what? The array name with only one subscript, then it is we got referring as the one-dimensional array. The various sorting algorithms we have to using this one. Okay, another thing is the two-dimensional array means what? The data can be stored in the number of rows and number of columns. It's a table like form means what? We have to using as the two-dimensional array. Okay, one-dimensional array means what? We have to using only one for loop. We have to accessing the elements. Two-dimensional array means that rows we got accessing one for loop and columns we got accessing the another for loop. Then you can easily access the data. Okay, how to read the data? A of just a side A of I. That means what is a one-dimensional array. A of ij. This means what is a two-dimensional array can be invoked. Okay, so normally wherever we got to using this application of an array, the array can be efficiently managed and store the database and records. Here we got to helping the sorting algorithms. Okay, many number of the data structure it can be used for implementing that one. Either the stack. Okay, the stack also we got to used for implementing your array can be used for implementing the stack and queue and heap and hash table. Any data structure can be accessed by means of using this array. Okay, because the stack can be array implementation of stack, then linked list implementation of stack. Okay, likewise. Okay, the various way can be used for accessing these data types. Also, the array can be used for the CPU scheduling. Okay, you know, you got to using the allotting the time slot. Okay, for accessing which time can be used for accessing which type of the data, then which elements can be accessed. We have to giving the priority or not. Just we have to checking for all. We have to using this CPU scheduling. You got to allocate the time. Okay, for accessing the data. Next thing is the linked list. Okay, linked list means what is also the linear data type. We have to storing the elements as the not contiguous the memory location, but we can accessing via the pointers. How do we got to access? Normally, each node consists of the two fields. One is the data field, another thing is the link field. The data field contains the elements value can be available, and link field contains the address of the next element. Okay, initially the first field. Okay, the node consists of the two elements. First field consists of the data part. It contains the data, and next part contains the link part. Okay, that is the address of the next element. Okay, likewise we got to insert all the values. Then whenever you got to reaching at the end of the node, so that time here only the data field is there. There is no link field. So that field can be we got it denoting as the null. Okay, also the head pointer can be pointing to the first node. And there is various types of the linked list can be available. Singly linked list and doubly linked list and circular linked list. Okay, singly linked list means what? The node consists of only the two fields. One is the data field, another thing is the link field. The link field what will do that? It can be pointing to the address of the next node. Okay, likewise the 5 is the first node, and 10 is the next node, and 15 is the another node, then 20 is the next node. The last node is the null pointer, so you got to write as the cross mark, otherwise null. Okay, likewise you got to denote it. Another thing is the doubly linked list. Doubly linked list means when you singly linked list, what is that? The data can be moving in only one direction. Okay, the backward direction is not allowed, but in doubly linked list, both directions the data can be moved, because here the node consists of the three elements. One is the previous element and the data field and the next field. Okay, the previous elements means what? Here address of the previous nodes can be we have to storage, and then we have to storing the address of the next node can be pointing to the address of the next element. Okay, likewise you got to move it. So whenever you got to reaching as the forward direction, the end of the node, okay, can be reached means what? Then you got to write as the null, okay, null point. Then reverse point, that is a backward direction means what? We got to move from the 20, 15, 10 and 5 automatically. Okay, then last field is the null terminator. Okay, likewise you got to move in the doubly linked list. And there is a circular linked list. Circular linked list like the same as the singly linked list, but the feedback can be provided to, okay, this circular linked list. Feedback means what? The last node can be moved into address, which one? Moved and pointing to the address of the first node. Okay, this way you got to point it. Okay, you know the each field consists of the two nodes. One is the data field, another thing is the link field. Okay, last field what is that? The data node is available as 20 and the address of the next node can be pointing to address of the first node. Okay, likewise it's a feedback. Okay, it's referred as the feedback. It is called as the circular linked list. This is the various types of linked list. Here, look at here the head. Okay, data field and then next means what? Link field. The link field can be pointing to the address of the next node. Okay, likewise you got to pointing to other nodes. The last node you got to pointing the next field can be pointing to what? You got to referring as a null. Okay, it's a singly linked list. And doubly linked list what? The head can be pointing to the previous first and thing is what? The next node can be pointing to the previous and next node can be pointing to the previous. This way you got to point the last, the next node to be null. This is a doubly linked list. And wherever you got to using this linked list, likewise your arrays, wherever you got to use for this array and stack implementation and queue implementation. Likewise only the linked list also used for implementing the other data structures, the stack and queues. You have to use this linked list and the linked list can be efficiently used. Okay, we have to representing this sparse matrix also. Also, we have to displaying the various image containers. Okay, we got to the past container, past images which one, then current image which one, then next image which one. Okay, easily we have to visit it by means of using this linked list. Also, we have to performing as the undo operations. Okay, the various, it can be used for linking the various allocation of files. It's also used. Okay, another thing is the stack data structures. Okay, the stack means what? It also the linear data structures. Okay, stack means what? It is whenever the insertion and deletions can be performing as only one n. That is called as the top. The insertion operation is called as the push operation and deletion operation is called as the pop operation. Now you have to see the figure. Initially the stack is empty. So that time the top is equal to -1. Then you have to insert the 1 and insert the 2 and insert the 3. So each time what the top value can be incremented by 1. During your insertion time, the top of the value can be incremented by 1. Then whenever doing the push operation, so that time the top value can be decremented by 1 because the 3 can be removed. Then 1 and 2 will be remaining. Okay, likewise you got to see here 10, 20, 30, 40 is your data. The data can be pointing, the top of the element is what? Is the 40. Next we got to push the 50 means what? The top, the value can be incremented by 1, it becomes as the 50. Okay, again we got to referring as the peak. Peak means what? Which element is the top of the node, that value to be returned, that is called as a peak. The top of the element value to be returned. Another thing is the doing the pop operation means what will do that? The 40 which and 50 can be removed first because the top of the element can be removed first because all of you know that the stack means what is the last in first out. Okay, which input can be lastly given as the input, that values can be removed as first output, that is called as the LIFO. This is stack representation. How do we got to represent the data? Okay, either the array or structure or pointer or linked list, the various way can be used for implementing the stack. Okay, the stack can be normally we got to use the arrays or linked list can be used. Now depth first search can be available in graphs. So here the backtracking use means what we got to using as a stack. Okay, suppose breadth first search we got to using in graphs means what, so that time we got to using as a queue. And what are the basic operations can be performing on stack? Push operation means what? We got adding the new element on the stack means what is called as the push operation. And pop operation means removing and returning the top of the element from the stack means it is a pop operation. But push means insertion, that is addition of element. Push means insertion, pop means deletion or removal of the element from the top of the stack. Okay, whenever the stack is empty, so that time you can't able to do the pop operation because already the stack is empty. Then how to do? The likewise is full means what? The stack is full, so you can't able to do the inserting the new value. Okay, the push operation we can't do during the pull. Okay, the stack is full means what? You can't able to insert the operations can be declined. Also the peak means for returning the top of the element on the stack. Okay, here the stack can be using pointing the top of the element we are using as a top because the top can be used for insertion and deletions. Already we seen that the push operation means what? Insert the element into the stack. Okay, we are using as a push operation. Normally just see the diagram. The stack consists of initially 10, 20, 30. The top of the element can be pointing to 30. Now we got to insert the new element is 40. Okay, then after that the 40 can be inserted into the stack. This is called as the push operation. So initially what will you do that during our new value insertion time? First of all you got to check the stack. Okay, if it is full or not. If it is full, you can't able to add the new value, then exit from the stack. Otherwise what? If it is not full, so that time increment it up to one position and we add the data element to the particular location of the stack. Okay, so this process can be which one? Whenever you got to inserting the value, so that time this process can be repeated. Another thing is the deletion operation. It's a pop operation. Pop operation means removing the element from the stack. It is called as the pop operation. Okay, look at here the figure A, B, C. Normally, now initially the C is the top of the element. Now the C can be removed. Okay, so that time after the removal of the C, the top value can be decremented by 1. Now only the what? The A and B only remaining, the top of the element can be pointing to B. Okay, what's the algorithm to be followed means what? First of all, we got to check it if the stack is empty or not. If it is empty, we can't able to delete the data. Otherwise what? You can access the data which one is the top is pointing. Because the elements can be insertion and deletion, both can be performing as single n. That n is called as the top. Okay, you got to decrease the value of the top by 1. Okay, this value is also the decrementation repeatedly executed. Okay, during your pop operation. And then operation on stack. Okay, whatever the operations already we seen that. So peak operation is full, is empty. Okay, this way so many operations can be available. The peak means is the top element can be returned. Okay, there is a top of the element can be returned means the peak functions can be used. And this full function means what? Check whether the stack is full or not. Is empty means whether we have to check the stack is empty or not. Okay. Another thing is the stack data structures. Already we checking. Okay, the stack is full or not. How do we got to check? During your push operation, the top value can be incremental. Okay, whenever the top value can be reaching as well, the top equal to initially, the top equal to -1. During our insertion time, the top value can be incremented by 1 by 1. Okay, after the pop operation, the top value can be what? Decremented by 1. Okay, finally, the empty stack can be getting. It's a sample program. Okay, initially, what will you do that? So, first of all, main function, just you got to doing the push of 44. Okay, so that time what you go to the push operation. Push operation, what is that? Here, just we got to see here, it's a push operation. What is that? During the push operation, whatever the 44 can be accepted as the data. Okay, if it is full, then if it is not full, then the top value can be incremented by 1. Then the data can be moving to the top of the stack. Otherwise, what? You can't able to insert the data because the stack is full. Okay, this way it can be displayed. Likewise, okay, the push up 10, push up 62, then push up 23. Okay, this way you got to store the value one by one. Now you got to check it. What is the element as the top of the stack? The peak functions to be referred. So that time initially 44, next 10, next 62, next 123. For which values can be top of the element? As a 123. Now we got a referring the peak means what? The top of the element to be return. Okay. Here what? Look at here. Here return stack of top. The top value to be return. Another thing is we have to check it what? Next thing is empty or not? You have to check it. Is empty means what? You can't able to do the pop operation. If it is not is empty, then you have to do the pop operation. In pop operation, what is that? Just you got to check it. If it is not empty, okay, the top of the stack can be which one? Which values can be available in the top of the stack? That values can be moving to the data. That value can be decremented. That will be deleted. Then the top can be decremented by 1. Then returning your deleted data. Okay, otherwise what? You can't able to do the which one? Pop operation because the stack is empty. Okay. Another thing is here you have to check it. If the stack is full or not. If it is full, then the true can be returned. Otherwise, the false can be returned. You have to using the ternary operator for doing this operation. Okay, is full function already we have to return. Okay, which one? The stack is full or not? You have to write the function. Whenever the top is equal to reaching as the maximum size, because here we got to referring as the maximum size is 8. So whenever it can be reaching as a 8, so that time it can be returning 1. Returning 1 means what? The stack is full. Otherwise, the stack is which one? Not full. Another thing is the stack is empty or not. You have to check it. If it is empty, the top is equal to -1 if it is empty. Otherwise, 0 to be returned. Okay, the application of the stack. Okay, previously we studied about various operations performed by stack deeply. Now we can see the application. It's a evaluation and conversion of the arithmetic expressions. And parenthesis checking and reverse of the given string and then memory stack. Okay. Then during your function call and your virtual machine JVM, we have to using as the stack for performing the operation. You know, the evaluation of the arithmetic expressions, that means what we got writing as some of the expressions can be written, the 5 plus 3. That means 5 plus 3 means what? Just as 8 can be returned. This is normal symbol. Okay, likewise the 5 as is 3 plus 2. This way we got write means what? 5 as is 3 means this is 15. Okay, another thing is plus 2 means 17 value to be returned. This way how to do performing this data by means of using a stack. Okay, this is evaluation of expression. Because you know the various forms of the data traverses can be surveyed, the data conversions can be surveyed. Okay, either data expressions can be infix or prefix or postfix. The various types can be surveyed. Infix means what? The operators can be placed in between the operands. That is called as the infix. And prefix, the operator is placed before the operands. Then postfix means what? The operator is placed after the operands. Okay, so this way how to convert one to another expressions. Also, we have to conversion of one expressions into another expression. Infix to prefix, prefix to infix. Okay, infix to postfix, likewise vice versa. You have to performing by means of using a stack. Another thing is the queue data structures. The queue means what? This is referred as the first in first out. Okay. First in first out means is which data can be come first. That data can be come out first. Okay. Okay, that is which data item can be stored first, that will be accessed, that means retrieved first. Okay, that is called as the FIFO, first in first out. Normally you know, you got to see as the one queue in any of service means what? Those who are coming to the first, that persons can be move first. Okay, likewise see the figure is a friend. Okay, the friend point is the which one? The deletion point. Rear point is called as the insertion point. In stack, what will you do that? The insertion and deletion both are performing as the single end, that is called as the top. But here in queue, the insertion point is called as the rear. Okay, so we have to performing the insertion operation is called as the NQ. NQ means what? Addition of the new elements. Then friend pointer can be used for deletion of elements. That operation is called as a DQ operation. Here, look at here. Here you got to insert the value, that is the NQ operation. Initially we got to insert the 3, after 4, then 5, then 6, then 7, then 8. Now you got to insert in the 9. Okay, this way you got to insert the value. Okay, that time the DQ the operation. Okay, the previously the 2 can be so means that will be removed first. Okay, so first in, first out. So the 2 can be initially away means what? That values can be removed first. Next we got a removal can be performing as 3. Next 4, next 5. This way only you got to removing all the data. So whenever the stack is full, so the queue is full, so that time you can't able to insert the data. Okay, whenever the queue is empty, so that time you can't able to delete the data. This application wherever you got used. Okay, during our handling the website traffic, you got to handling, the queue can be followed. Okay, which can be coming to the first. Okay, that can be moving to the first. This way you got to write it. Another thing is the we got a playlist of the media players. We got a maintaining purpose, the queue can be used. Also in printer, the print queue can be used for serving the which service can be coming to the first, that service can be moving to first. Okay, also the task scheduling, okay, which can be coming to the first, that will be scheduled to first. Likewise you got to the queue can be used for job scheduling in our operating systems. Another thing is the okay, up to this we got to study about the linear data structures. Now we got to study about the non-linear data structure, tree and graph. Okay, the tree data structure. The tree means already we seen that it is a non-linear and hierarchical data structure. The data can be arranged in a tree form. Okay, just you got to see as the top of the node is called as a root node. Okay, each node consists of the 2 nodes. One is the left side, another thing is the right side. Okay, it's a root node. It consists of the 2 elements, 2 or more elements, no problem. Okay, this element is called as the left subtree. It is called as the right subtree. Okay, again we got to condenses some of the elements. Okay, this way we got right. Okay, the root of the node, the first node is called as the root of the node. Okay, we got to referring this is level 0. Okay. Another thing is the level 1, then level 2, level 3, this we got right. Okay, which here we got writing this is one of the parent. Okay, parent of F, G and H. So F, G, H is called as the brothers, that's a siblings. Okay, we got to referring siblings means what? All are from the same parent. Okay, then we got to referring it as a sibling. Okay, another node is the parent node. Parent node means what? The node contains the children, then we have to referring as a child node. Because the node is a D, and then E, and then B, and then C, and then A, all are referred as the parent node. Because all are having the children's. But here the I, J, K, F, G, H, these all are called as a child node because they doesn't have any other node. Okay, the parent node. The parent node means what? The immediate predecessor of the node is a parent node. Likewise, the P is the parent node of D and E. Okay, P is the parent of D and E. Okay, another thing is a child node. Child node means what? It is the immediate successor of the node. Okay, it's called as a child node. Okay, the D and E is a child node of B. Okay, D and E both are the child node of B. Okay, B is the parent, D and child is a child. And then root node, the top of the node is called as a root node. Here the A is called as the root node. Okay, A is called as the root node. And then leaf node or external node. Okay, the node does not have any child, means that is called as the leaf node. This is the I, J, K, E, G, H. These all are we got to refer as the child node. Another thing is the ancestors of node means what? Here the A, B are the ancestor of the E. Okay, because you look at here, A, B is the ancestor of E, because he is the which one? Successor. He is all the descendant. Which one? The E is called as a descendant. B and A is called as a successor. Okay, like this the descendant. And sibling means what? The children of the same parent is called as a sibling. And level means what? You have to counting the path from the root to that node. The root node is 1 means what? Again the other node is we got incremented by 1. Root node is 0. And next level is the 1. And next level is the which one? 2. And next level is the 3. Like this you got to storage. Okay, another thing is the internal node. The node, at least one child is called as the internal node. Neighbor node means what? The parent or child node. Okay, can't call the neighbor node. And subtree means any node, the tree along with its descendant. That is called as a subtree. Okay, here it is called as one subtree. Okay, it is called as one subtree. Here also called as a subtree. Like this will write. And then application of tree. Okay, the heap is the data structure we got to using as the arrays to implement the pediatric queue. Okay, you got to achieving the pediatric queue, you got to go for the heap data structures. We can easily access because the heap data structures we got to see about it means what? Here the keys can be available and then some hash functions can be available. You got to link it. Okay, how do you got to accessing the data and everything of this we got to done. And then B tree, B plus tree, what implementing the indexing. That means of using the set tree. And also the syntax tree. Syntax tree used for your compiler designs, how to scanning, parsing and generation of the codes, and how to evaluating the expressions, what things can be done. And spanning tree. Okay, the tree without any cycles means we got referring as the spanning tree. And domain name servers, it like as a tree string, data structures we got to referring it. In case the tree, another form is called as the binary search tree structures. Okay, here the storing and data in our order function, shorted order. Because the binary subtree means what? Only the two children are there. One child is called as the left child, another child is called as the right child. Here the searching, insertion, deletion, all operations can be performing by means of using as the tree. Here, look at here, it is. Here the binary search tree is the top of the node is 11. And the thing is left child is called as the 7 and right child is called as a 15. Just you have to note on it. This is the left side of the root node is called as the lesser value and right side of the root node is called as the greater than value. Okay, that is so 11 is a 7 and the thing is 7 means lesser value is 4 and greater value is 9, but this 9 does not exceed this 11. Okay, likewise 15 is a right as a 10. Okay, not as a 10, here you got writing as 12 or 10, anything you will write. Okay, here the 11, above the 11 you got to write it. And then here the 15 and then 25, like this you will write. Okay, the application, self-balancing DST can be used, also extracting what's the minimum value and what's the maximum value for 0 of n time, because we got to easily find out because all values can be available in an order. So you got to check it with the root node means what? The time to be, half of the time to be reduced. So you got writing big O of log n time. And then the many algorithmic problems, we got to find out which one is the smallest or greatest element, and then tree map and tree set, okay, in Java or set and map in C++. We got to using implementing by the red block tree. Okay, can be used. Another thing is the graph data structures. It is also the non-linear data structure. It consists of the number of vertices and edges. Okay, the finite number of the vertices and edges can be available for parallel nodes. Okay, you got to finding what is the path and then degree and adjacent vertices and connected components. The various terminologies can be available. Yeah, this is called as the vertices. 5, 3, 1, 4, 2, 6. It's a link between these two is called as the edges. Okay, so the node or vertices can be referring as whatever the individual entries can be available. You have to refer it. The edge is called as the connection between or relationship between these vertices is referred as the edges. Then application, the resource allocation graph. Okay, we have to using this graph. The OS can be using this RAC. Okay, RAG. Another thing is World Wide Web also we got to using this one, and the real world, the Google Map also we got to using, and the social network. Okay, the lot of network can be available. We will see on later what are the lot of real world examples can be solved. Just you got to see about the Google search, the hash table tree graph can be used, then social network the graph can be used, and GPS the graph or grid can be used. Okay, nowadays, okay, without GPS we didn't nobody is go to any other place or anything. The graph can be helpful for going to that, an online ticket booking, and then path finding, and everything can be the real world example for what type of the data structures can be used. Okay, thank you for all viewers.